From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
There are two bottlenecks for powder bed fusion processes. One is size, and the next is speed. Okay, so you can't make large-scale components on powder bed fusion processes, and the speed is also very low. So this is where DED comes into picture. So how do we make this additive manufacturing faster and also at the same time build large-scale components? So I don't think that these two are competitors. I would say they complement to each other. So each process has got its own niche application. So again, DED process is also it has several different processes. Underneath, I would classify DED based upon feedstock. Okay, you can apply either powder or wire, and even under powder or wire, you can have different heat sources. So this is how we'll create a unique AM process. You can have a different permutation combination for a heat source and also for a feedstock.
That was Yash Bandari. Yash is an additive manufacturing project manager at Meltio. Yash has over 10 years of experience with directed energy deposition 3D printing processes, having had the opportunity to work with all three heat sources, including arc, laser, and electron beam. Meltio is an AM machine manufacturer focused on DED, offering a solution that can use either or both wire and powder feedstock. As you can probably guess from the introduction, we're going to dive headfirst into a conversation about DED processes and their evolution in the 3D printing sector. Thank you so much for joining the show today. Why don't we just get started with a little bit of background on how did you start in maybe the additive manufacturing space?
Sure. Yeah, thanks. Firstly, thank you very much for having me on your show. I've been following your show for quite a long time, and I've been listening to good speakers and their background. So I thought, why not have a conversation with you? Thanks. Thank you very much for having me again. My background is manufacturing engineering. I started my venture into additive manufacture in around 2010. At that point, 3D printing, additive manufacturing was a buzzword actually, and people were making nice toys out of powder plastics, and that's when the desktop metal printers or desktop printers, they were getting coming into the limelight actually. So there was a lot of traction. People were talking more about it, and that's when I also got interested and started my master's thesis in metal additive manufacturing. And I started with big because I think thinking big and also making large scale parts will make more sense for additive manufacturing, more savings, and so that's how I got into DED processes. So I started with wire arc additive manufacturing, and I didn't plan for a PhD. After that, I was always interested to go into consulting sector, like a banking sector, because I was always a big fan of interacting to people, get to know more about the people, their perspective. But during my master's thesis, I had an opportunity to present my thesis work at an international conference, and the organizers, they liked it, and I was lucky enough to win a scholastic award during my presentation. And that's when I realized the potential of large-scale additive manufacturing DED processes. And then I took a bit of time. I worked for an automobile company as a technical manager for about 9 months. And during that 9 months, I spent quite a bit of time just thinking about if I need to do a PhD or not, and what are the different opportunities, because I got to plan my life as well after the PhD. So I got an offer from Cranfield University, because at that point of time, I think Cranfield University UK was the only university which was doing a good job, a good work in wire arc additive manufacturing. And then I approached Professor Stuart Williams, and I had to go through a couple of rounds of interview, and that's how I landed in the UK. So it was a big leap from India to the UK, and I finished my PhD in 2017. And again, it was in one of the conferences I learned about Oak Ridge National Lab, that they were also, researching large scale additive manufacturing, metal additive manufacturing, and it was kind of, they were just about to start, especially wire based additive manufacturing. So I thought, I could use my skills, to develop the process and work with a, highly reputable organization like Oak Ridge. And that's how I got into Oak Ridge, big leap from the UK to the US. It was a good opportunity, working with diverse backgrounds. It's a big organization, Oak Ridge National Lab, 5,000 people. And again, during my postdoc at Oak Ridge National Lab, I realized that I'm not an, like research or basic science is not my cup of tea. I realized that after talking to many industry people, my interest and where my focus lies, because there has been a less demand basically for the people who have both technical and business background. But I always was interested, in having um, this technology adapt to this new technologies. So that's when I came to know about EWI during one of those conferences, and that's when I joined EWI, and then later Meltio. So I'm the product manager here at Meltio, and it's about 6 months, and it's been a roller coaster ride here in Meltio. It's a small startup company. It's a medium size for a DED company, but it's been a roller coaster. There has been so much of enthusiasm, for a startup like company.
Awesome. And so going back a little bit, so you'd spent some time at Oak Ridge. I've had the pleasure of going down to the MDF, the Manufacturing Demonstration Facility Center. I forget what the last letter always is, but
yeah, the Manufacturing Demonstration Facility.
For those who are just listening and may not be familiar with kind of Oak Ridge's heritage in additive manufacturing, can you describe a little bit of what's going on there? Because I think it's pretty neat of kind of what's going on there, and certainly for someone that's worked there, probably some added insights of kind of the focus, like what does a national lab have to do with additive manufacturing?
Yeah, absolutely. If I wanted to say something in a nutshell, I would say this way. So if anybody wants to learn about additive manufacturing in general, if anybody wants to see different processes, if anybody wants to know more about the processes, materials, then I think Oak Ridge National Lab is one shop stop. Because on their shop floor, they have literally all processes, all machines from major manufacturers, different brands, and their specialization. They have got good expertise in robotics and toolpath planning softwares, materials, which all form a vital part, for additive manufacturing. So, so what is it to do with the National Lab? Of course. So one of the main things that National Lab is investigating is the national security, right? So this additive manufacture is one of the pivotal, which will help for the national security. So it can be in any in any sector, can range from aerospace to space to even defense and marine. So they have a good collaboration with army, defense, and then they're working on all innovative projects, so as to help this army, defense go for the next mile, and with the new innovative studies. So when I joined MDF, it was a small organization, but now it has like tripled, or like 4 times what I saw in 2017. And yeah, they are in the limelight for all the good reasons. They've got good materials background, scientists and robotics, and yeah, I feel myself to be lucky. At the same time, I really enjoyed my stay, rubbing shoulders with the great scientists, and yeah, all of them, and I had exposure for literally all different AM processes that I didn't work on previously.
For sure. Probably a little bit better weather in Knoxville than in Cranfield, I would imagine.
Absolutely. I mean, you lived in the UK, so well, I mean, it's never summer. Like there's a saying, sun goes as a tourist to the UK, not to actually live in, as a tourist actually. So It was all chilly and rainy during summertime. But yeah, Knoxville was a different experience, a transition, and yeah, that part of the US is I think it has nice four seasons and Smoky Mountains right next to it. So we had many fun activities.
So getting back to additive, so you spent kind of your career looking at, or a lot of your career looking at kind of the DED processes. Can you just give a kind of a high level, like what's DED? There's several types of kind of subcategories in that. Kind of what's the focus of kind of your research, and then maybe going into kind of what does Meltio do in the process?
Sure. Yeah. So DED, they are another class of additive manufacturing. So in general, I classify additive manufacturing into two types. One is powder bed fusion processes, and the next is DED process. So the main difference is between these two big class of processes is you don't need support for DED process. I mean, that's not the deal. But for powder bed fusion process, you have a nice bed which acts as a support, and you have two main processes under powder bed fusion processes. But yeah, when it comes to DED, there are two bottlenecks for powder bed fusion processes. One is size, and the next is speed. Okay, so you can't make large scale components on powder bed fusion processes, and the speed is also very low. It's about like 0.1 grams per hour, which is very low compared to the DED standards. So this is where DED comes into picture. So how do we make this additive manufacturing faster and also at the same time build large scale components? So I don't think that these two are competitors. I would say they complement to each other. Actually. So each process has got its own niche application. So again, DED process is also it has several different processes. Underneath, I would classify DED based upon feedstock. Okay, you can apply either powder or wire, and even under powder or wire, you can have different heat sources. So this is how we'll create a unique AM process. You can have a different permutation combination for a heat source and also for a feedstock. So I was actually fortunate enough to have worked on all four main DED processes at different organizations. So one of the main advantages, one of the main advantage of DED process, apart from size, is even its cost compared to PBF processes. So this is where Meltio comes into picture. Okay, so we want to make this DED process as affordable as possible. But not just that, how do you leverage the advantage of different feedstocks? Okay, so most of the competing technologies in the AM market, they either apply powder or wire, but each one of them, they have their own advantage, right? So Meltio here, we leverage the advantages of both powder and also wire and combine them inside a single machine. So thereby leveraging the, basically you can make intricate parts, fine details with powder. You can make quick, solid, thick parts using wire at a cheaper cost. So depending upon the application, depending upon the geometry, material, you can either switch from powder to wire or vice versa inside our machine. So I think we are the only ones in the additive market to have this kind of technology. So all other technologies, they either have either powdered or wire as a feedstock. But in our machines, we combine both powder DED and wire DED inside a single machine. Basically, you don't even have to change the laser head. So the laser head, it has provisions to feed both wire and powder independently or simultaneously. So again, this creates a whole lot of avenues with respect to different types of alloys that you can make. You can have you can switch between materials whenever you want, and different types of researches is also possible, right from functionally graded materials to high entropy alloys to metal matrix composites to shape memory alloys to low thermal coefficient alloys. So all of these are possible on our machines, and probably this is one of the reasons why we are seeing a lot of interest, especially from research organizations like universities and national labs.
And suppose that kind of flexibility is a double-edged sword, right? Like you can try a lot of different materials, combinations, part geometries, but probably from where you're sitting as well is like you have so many options to explore and industries to talk to that um, it's I'm guessing it's overwhelming at times to say like where do you start, right? What are you trying to forecast of what's the market going to be, what sorts of parts, and like you could kind of manipulate the machine or the feedstock to do a lot of things well, but at some point you have to kind of focus. So do you have kind of a kind of stereotypically, I would, or kind of at a high level, what sorts of parts, what sorts of kind of case studies that are you guys seeing as kind of like, hey, like when we talk about DED, like this is what resonates with our customers or potential customers?
Yeah, I get asked this question a lot of times. So, in a nutshell, what I want to say is our technology is versatile. Okay, so we are not confining ourselves to aerospace companies who have been the forefront for the last 20, 25 years for metal additive manufacturing. But not just that, you have applications even in marine, defense, and oil and gas, automotive. So we don't want to constrict to only one sector. So we can make parts as long as it creates a business case and also it is viable to print using our technology. Okay, so any typical alloy or any customized alloy that is available in the form of powder or wire, they can be applied, in our technology actually.
And it's
And
a different type of powder as well, too. Like, well, not the alloys can overlap with powder bed fusion, but in terms of particle size distribution and shape, it's a little bit. It's a different kind of spectrum than powder bed fusion. Is that right?
this is where DD process. This is where I like about DD process. They don't really ask you to go for powder bed fusion powders, which are very teeny tiny. They can range even less than 20 microns as well, and they so quality is foremost when it comes to PBF processes. But in case of DED, as I said, it's kind of different. When it comes to the powder quality, you can get away with large size powder particles too. We use anywhere between 45 to 90 microns, which is just the standard particle size in the market. And you don't have to worry too much about the quality actually, as you would worry in PBF processes, because you have a nice bigger melt pool when you compare it to PBF process, which is very teeny tiny, and even a small amount of moisture or humidity levels or temperature levels difference will create a lot of porosity when you're building parts actually. So this is where powder DED is slightly easier, and you don't have too many process parameters to play with as well. In PBF, you have this laser scan speed, feed rate.
Lasers, right?
Exactly, a lot of lasers and upscaling, downscaling, and all these things. But in powder DED, just like three main parameters, and you can actually see the melt pool. You can actually see the part which is growing. It's like an what should I say? It's like a baby. You can see in the in the stomach of mother. You can actually see it growing. But in powder bed, it's all immersed. Can't see it unless it comes out. And when it comes to monitoring a DED process, it's slightly easier because you have different ways, different orientation, because you can actually see the part. So this is where the qualification things comes into picture. This is where some sectors are very stringent about their properties, qualification, certification compared to others. So it depends upon which sector, what is the application we are working on. But yeah, coming back to your original question about the versatility, we don't focus on a particular sector. I think it's since the technology is versatile, since every technology has their own favorite material, and you can apply any material in this case. So you can apply in any sector actually.
And I suppose there's some potential as well to potentially mix materials as you're building. Is that?
Oh yes, oh yes, yeah. So you can mix materials both in the form of powder and in the form of wires. and also in the form of powder and wire. So this creates again a lot of options and avenues. There's a lot of interest in mixing powders to create customized alloys to enhance properties. So that has been there for quite a bit of time, and there have been many companies who are doing this kind of stuff. And mixing wires, you can have similar wires or dissimilar wires. Similar wires will give an increase in deposition rates, and dissimilar wires you can make customized alloys, and you can have outside material to be different and inside material to be different, rather than having one same material across the thickness. Again, you're thinking about functionality and saving costs and time. But in our case, we can also mix powder and wire. So traditionally, I've just seen in the universities, couple of universities, where they had a wire feed system and also a powder feed system. Arrangement was kind of complex, and there was too much of manual intervention. They needed two, people to turn on the powder feeder and wire feeder, and then make sure that both of them, they integrate, the synchronize at the same time. It was like a hide and seek game going on. But on our system, I think it's just you can program it, you can do it automatic or manual, whatever the user would like to have it. But again, having a provision for wire and powder, it opens up another area from metal matrix composites. I think this is one of the area that not many people they want to get into it, because until now most of the people they knew about this FGMs and they worked on it, and I think it's at a point that there is nothing much new going on in the universities actually. But when it comes to MMCs, because of the lack of equipment itself, I don't think they've done good amount of investigations. But with this the technology, with this arrangement, I think there will be a whole different scope of works that can be done on Meltio's products.
And what's your sense as you kind of worked with Meltio and engage with customers and universities? Can you describe a little bit of like what's the typical organization like when you kind of are working on selling the machines and selling the technology into companies? Are you talking with a lot of materials engineers? Is it CEOs who see the technology? Kind of what's that dynamic like these days with kind of who you're interacting with?
Sure. Yeah, that's an interesting question. So yeah, I talk to, I think, people who are just entering into additive manufacture, to the people who have been like working for 25 years, like big DED companies actually. And I see everybody's background, from where they're coming. It's evident from the questions that they ask. Yeah, in a nutshell, because our technology is very unique. It is not, found in the textbooks or in the papers, articles. So this is where it keeps us in the hunt compared to other technologies, and we have our own unique things which are proprietary and which make sense a lot of from additive manufacture. So yes, I do talk with manufacturing engineering background and with materials engineering, and sometimes people like your background, they grill me with the material questions, related questions, but that's okay. That's okay. So these are some things. We are also still at an medium TRL level, so it helps us to even lay our R&D. So this is one of the things what I do as well. I oversee R&D and come up with more innovative things that people would like to see in their equipment. So a couple of people who come from non-AM background, they were more interested in just looking at the data sheets, and that's it, and a couple of case studies basically. We have this part, how much will your process save? It's as simple as it. They all talk about numbers and return of investment. When it comes to actual people who have been working in DED for the last 25 years, they're more interested into the inner details, the microstructures, and the neutron diffraction, which I'm again still coming to know because of my background. And yeah, they are more into these minute details, and how your process will make a difference in the parts that they want to make it. and they're also looking at a high TRL level. And it's a good mix, I should say, because we can't take this technology. We can only take this technology to an extent, but we need these big companies also to work with us to help qualify the process, materials, and the parts that we make. So yeah, we are currently working with some aviation companies and power sector companies who have been showing a lot of enthusiasm from the standpoint from price standpoint and then the technology capability.
And can you talk a little bit too about the general workflow more on like the software and design piece of this? Because there's been certainly a push in the additive manufacturing sector to build a lot of software tools for simulation and build management for kind of the traditional powder bed processes and support structures and things like that. But what's the environment? What's the ecosystem like on the software side? I mean, you guys are building a machine, but there's always software elements to that, whether it's interface or just helping your customers think about all the different options that they have for feedstock and other parameters.
Absolutely. Yeah, software plays an important role, especially for DED processes. It might not be that important maybe for PBF processes, but for DED because of two reasons. Because you have a very big melt pool, and controlling that melt pool is not easy compared to smaller melt pools on PBF. And at the same time, not just controlling the melt pool, and how do you build a part without defects? Okay, so like traditionally, what people have been using in DED arena, because I've been talking to different people from the industry. So since this process does not require support, what people have been using are reverse machining strategies. Okay, so if you're milling a part and you just reverse the toolpath strategies and they are applied for DED processes. They might work well for some geometries, but they can't be generalized for all the geometries actually. Because just for an example, for machining process, if you want to do an intersection, you go twice. But in case of additive, if you are going in these two directions, you would have it built up at the center, right? So you have to have a different strategies, or you can't use the reverse machining strategies for DED process. So we work with different software companies as well. We work with Delcam, or no, it's called PowerMill. Autodesk. And they have been doing a good job for the last 10 years or so. Traditionally, they have been a machining company. Toolpath softwares they were providing for machining. Even they started with the reverse machining strategies, but then they realized that there's more to that actually, and they have been creating custom post processes for different companies and different machines. And they have been helping us a great deal actually. And and also it depends upon different geometries. So for different geometries, you have to have different toolpath strategies. And also this is only from manufacturing standpoint. And from material standpoint, okay, you can't use a particular strategies because this will result in a different cooling rate, for example, which might be detrimental for microstructure or defects. So both have to be taken into consideration, and there has to be a trade-off as well. Because first and foremost, you have to build the geometry right to the dimensions, but at the same time, you should also not compromise on defects or microstructure. So all of these things have to be taken care for any DED software, and I think this is one of the myths. What people think it's software is simple and you can apply. But when it comes to qualification certification, I think this is software it shouldn't be underrated. Actually, it has to be one of the top priorities apart from the material studies and the other investigations.
For sure, and you see that as well in this process where it's not just about what's building. You have to. There's some interpretation of post-processing. What are you going to do after the fact, and how would you inspect this both in situ and then after it's being produced, right? So, I mean, everyone in additive is looking at those problems or
Absolutely.
challenges as it gets more towards production and use parts and getting out of just the serial process and larger.
So for maybe like, for one-off parts, maybe a simple software, which can take into consideration all of the things I mentioned before might be okay. But if you want to, build serial part production parts, I think there needs to be an additional step, basically, developing this closed loop control systems within the software, where it will also do in situ monitoring. For example, looking at the melt pool, or looking at the build height, or looking at the defects, and then developing the correction algorithms on the go, actually. So all of these things, they have to be integrated into the software. Probably this is one of the reasons why DED is not yet used by all companies to make their own parts, because it's still in the like medium to high TRL stage, and people are still working on what needs to be looked at, and what needs to be controlled, and what are the things that will go for the qualification, QA and QC, basically.
So we were talking a little bit before we hit record that you kind of do time on both sides of the country here, and so you guys are kind of R&D is based in Nevada, is that right?
Yes. So our R&D facility is in Nevada. But good news, we are moving to East Coast. It's just our CTO was from Nevada. He had been living in Las Vegas for quite a long time, so that's how he started this company, Meltio. But most of our customers and our main factory or the warehouse is in Spain. So right now, the time difference is 9 hours. So by the time somebody gets up, it's it's a sleeping time for somebody else. So yeah, we want to bridge the gap between our two locations, and just looking at from the geography as well, like the East Coast, or you're the first ones who will be knowing that we'll be moving to Florida in next couple of months. So we're all excited about it, and as you know, Florida has lots of aerospace companies, defense companies, and it's one of the welcoming states as well, in a way. So yeah, we will be operating from Florida, and this direct flight to Madrid, which is where our factory and our warehouse. And in the US, we do mostly R&D. So we develop our own lasers, optics, laser systems, powder feeders, and we integrated ourselves. We're not the company who buys off the shelf and then integrate. Probably that's one of the reasons why our integration is rigid, and at the same time, the cost is also affordable.
And so, given your kind of have a global footprint, is there any differences or any different focus points for different geographies that you've seen over the last few years of the technology, Europe versus the US? Are there any trends that you've seen?
Yeah, absolutely. I think so. This DED process. Let me take an example. But especially for DED processes, I think Europe was, forefront compared to the US. So they had probably because of presence of large, several aerospace companies in Europe. So they were actually the first ones. If not the first ones, more number of AM and DED enthusiasts, and that's how the DED process, more number of DED processes have been investigated in Europe. And then I think during 2010-ish, then US started investigating these processes, and suddenly there has been a huge interest from the US, and then the other follow-up countries, like Latin America, and then Asian countries also followed them accordingly. So yeah, when I talk to different people from different countries, I do it in a different way. Because for some people, GED process or even just metal additive manufacturing might be something easy to understand, or they have been looking around, just looking at what others have been doing in their own country. But for some countries, this is still a new process, and the type of questions they ask, and background they come from. I really enjoyed those conversations as well.
And how have you seen the you mentioned you do a lot of work with universities and larger companies. I mean, eventually, as this process of additive manufacturing scales, especially on the DD front, more and more kind of some of these small, medium-sized companies need in the supplier network are starting to get the technology. Has that kind of evolved yet? Is that kind of a stable network, so to speak, of kind
I
of
would
these?
say it's a combination. I would say some of the people, couple of them, they mentioned to me that one of the things which stands out is the cost of metal additive manufacturing. It's high when they compare our machines with I know PBF machines, for example. But at the same time, they want to venture into additive manufacturing no matter what because they know the advantages. So they're looking at different processes. They want to down select and then maybe pick one or two processes on their shop floor. So this is where most of the requests come actually. And universities, all the research, everything starts at the university. So there were a couple of universities like Penn State or other universities. They have been in this additive arena for quite a long time. So I mean, they know what the capabilities, but some other universities, again, they have, they're starting up this additive course, and then they want to incorporate this, different 3D printing processes, and some of them are quite new. So yeah, those experiences are also, worthwhile, and they have been also been exciting. And then the other end, on the power users, because most of the industries, they don't publish what they're doing. Isn't it? They have their own, they have their own set of standards for themselves, and they have been in this DED process for quite a long time, and they want to evaluate our process with respect to cost and all the savings and all the good stuff, and they're helping us with respect to certification, qualification. So like we see each of the customers to be coming from a different background, and their expectations are different, and then the way they conduct their research or investigations are also very different.
For sure. And kind of as we get towards the end of the conversation, for people who want to find out more information about kind of your technology or even see it, are there kind of places that you'd recommend? Are there upcoming conferences or ways that people can learn more about what you're doing at Meltio?
Sure. Yeah. I mean, we actually officially launched at AMA, Formnext actually. So that was in 2019. So we are a big fan of AMA and Formnext. That's where we see lots of AM users coming onto a common ground and then interacting. So Formnext and AM, we always attend these conferences. I know last year was was a different year, but I suspect even this year's Formnext might be virtual, or I don't know, but if they're happening in real, we will be there. And of course, we have our resellers in all big countries actually, right from North America to Europe to Asian countries. We have our resellers, master resellers. So if anybody wants to know more about our products, I mean, I didn't tell you more about our products, basically. I mean, we make small scale 3D printers and also large scale 3D printers. So there has been so last year was our first fully operational year, and there was a lot of interest for small scale, but now we are seeing a different trend. They're going for large scale additive manufacturing units. So yeah, if anybody is interested, they will see me in the conferences, either it is real or virtual. We will have our machines at AMUG, Formnext, and other different conferences as well. And of course, they can email me at any point. I like telling more about our unique technology, and even in general, any questions related to DED processes, or if they want any recommendations or suggestions which process makes sense for their applications, they can always DM me or ping me at Meltio's website.
Fantastic. Awesome. Well, I really enjoyed the conversation today, and I'll see you at AMUG in a few months, weeks.
Sure. Yeah, I'm more than excited, to meet you at AMUG for our panel discussion. Again, That panel discussion is also on DD processes, some of the myth busters, some of the challenges. So when we can talk about current status. If people are interested, they can register at AMA conference, and and then thank you very much for having me, and it was a pleasure talking to you.
Sounds good. And we'll throw up all the links to the website and videos and things when we post this as well. So thank you very much.
Okay, thank you very much, and you have a very good rest of your day.
Thank you.